Hi. Reasoning about programs in terms of assertions was pioneered by Tony Hoare, who in 1980 won a Turing Award for this work. He proposed what have become known as Hoare triples, shown here. The meaning, semantics of a program A is a proposition Q defining what is guaranteed to be valid after execution of A. Q is referred to as the postcondition of A. This postcondition can usually only be achieved under certain circumstances, which are called the preconditions. In the triple notation, these are expressed as P. If there are no assumptions needed to execute A, P can be the simplest possible proposition, which is just true. Read from left to right, if you know that P holds and you execute A, you'll end up in a state in which Q holds. Hoare triples can be used to reason about individual statements as well as full programs. For example, if your program first executes a statement A and then a statement B, you can sequence them, doing first A and then B. The result, postcondition of A, should be and then imply the precondition of B. In our context, the program A will be a Java method. Thus, we will reason about methods in terms of their pre- and post-conditions. If you write a method, what preconditions should you give it? Let's look at an example. Here we see a class for keeping track of your favorite books. You can see one method called merge. Its intent is to add new books to your list of favorite books. It does so by using Java's standard list class and its addAll method. Moreover, it notifies any listeners about books being added, so that, for example, push notifications can be sent to some phone. Does this method rely on any assumptions? Under what circumstances might this method fail? Can we turn these circumstances into explicit preconditions? Let's first look at the method's parameter, called books, which is just a list of books. Can we pass any book list into this method? Can the book list be null? No, it cannot. The addAll method used will throw a null pointer exception if its argument is null. Thus, our implicit assumption is that the book list is not null. Let's add this as an explicit assertion. Furthermore, the merge method should inform its listeners about successful book additions. An addition is successful if there is at least one book in the list. Let's add this as an assertion too, as shown here. But the assumptions are not just about the input parameter books. The method body uses the favorites instance variable too. Can the list of favorites be null? No, it cannot be null, since then we would get a null pointer exception when trying to add books to it. This we can also encode as a precondition, shown here. Last but not least, we want the books to be merged to be new. We only want to send out notifications for books not yet part of your favorites. Let's also add this as an assertion. This gives us a total of 4 preconditions. If they are met, the method can do its work. It can add the new books to the favorites and notify interested parties. The 4 preconditions given here are just one way of working with preconditions. We could have designed preconditions differently. For example, we can drop the requirement that the list cannot be empty. The desired behavior of the method would then be that if an empty list of books is added, nothing should be done. In particular, no push notification should be sent. This means that the method needs to be extended with an if statement to ensure that push notifications are only sent if the list is non-empty. With this if statement in place, we can then drop this empty assertion. We have made the method a little more general, it has fewer assumptions, but the price to pay is that the method itself has become a little more complex. We can do the same for the contains precondition. We can modify the method body so that it only adds new books. This removes another precondition and makes the method easier to call. Again, the price to pay is that the method itself needs to become more complicated. The method body now needs to filter out the new books, in some way not detailed here. If there are indeed new books, it should then add those and send out the notifications. The removal of these two preconditions illustrates that the choice of preconditions is ultimately a design choice. You are designing your method or your full API and are making choices about the precise circumstances under which methods can be invoked. These choices affect the callers of your method, who need to be aware of them. They also affect you as method implementer, since as you are dropping assumptions, you need to increase the complexity of your method to handle a wider variety of circumstances. Besides preconditions, we can also add assertions for postconditions. Postconditions describe a method's desired outcome. In this case, one outcome is pretty simple to express. The new books should be contained in the list of favorites. Again, we add this as an assert statement, this time at the end of the method body. In general, postconditions can be hard to formalize as Boolean conditions. Often methods have side effects that just are not so easy to express in a yes-no value. An example is the notification. The notification call is made, but it is difficult to express this as a Boolean proposition. Thus, pre- and postconditions do not cover all possible effects, but a hopefully relevant subset of the possible behavior. For more complex methods, postconditions tend to become more complex too. Another reason to keep your method simple. Here we see a method body with 3 different return statements. Each of these may have a separate postcondition. In general, the better coding style is of course to have a single exit statement with one easily understandable overarching postcondition. With multiple return statements or multiple paths, the effective postcondition is a disjunction of propositions. The method guarantees postconditions 1, 2 or 3 under different circumstances. In summary, thinking about pre- and postconditions is not just about adding assert statements. It is a design activity helping you to formulate precisely under which circumstances a method can make certain guarantees. The strength of the preconditions is a design parameter. The weaker the preconditions, the fewer assumptions the method makes, and the easier it is to invoke. The price to pay of weak preconditions is that the method itself becomes more complex. It always has to check under what circumstances it has been invoked and act accordingly. Postconditions formalize the guarantees that a method can make upon completion. The guarantees can only be met if the preconditions hold. If not, the method's outcome can be anything, no promises made. With weaker preconditions, the method may have to handle different cases depending upon the circumstances under which it was invoked. It then leads to multiple postconditions guarded by conditions on either the input or the current program state. For now, you can practice thinking in terms of pre- and postconditions by trying to formulate pre- and postconditions for any method you write. Once you have them, a natural next step is to try to add them as assertions to the code that you are writing. Later in this module, we will see how thinking in pre- and postconditions can guide not just method design, but also design of full APIs, and we will see how these pre- and postconditions can be used to guide test design.